Hi, in this video we're gonna talk about last time I was interfacing BMP280 with FRDM MCXC444, which is in I2C communication with BMP280. For this time, I'm interfacing BMP280 with a different kind of module, which is communicate in SPI communication. They call. So in SPI communication, they have four pinout, which is the MOSI, MISO, serial clock, and chip select. So these four pin out involve and VCC and ground as well for the connection for the power. So there are six pin out going to the FRDM MCXC444. So you can see each have this. They have a register same as before from I2C communication code. So for we have a type depth struct for the calibration. We have a chip select handling this time, which we have a chip select low and chip select high for the pin, basically for the SPI communication as well. So we make a CS BMP280 CS config function here, and we have an init function instead of the I2C init function. We have the SPI init function. Same, we set as pin marks here and config the SPI. Then we initialize the SPI master initialize. Then we have write register and SPI read register as well. Then here evolve, which is the chip select low function. Then there has a master transfer blocking in between them with the chip select high. So basically it's like sort of like we have low high for controlling the SPI communication. Then we have the read calibration here. Then we compensate the temperature and compensate the pressure. Then we initialize the BMP280 here. Then this is our while loop. So it will keep on running the while loop. The data keep on polling for this SPI communication. So what we have actually, we get from this default. If you want to get the SPI communication default, import SDK examples. We go to the respective boards. We go to the driver examples. We go to the SPI here. So let me see. Here. So this is the SPI. Then we go to the SPI underscore, which is the polling. Yeah, I take this as a reference. SPI underscore polling B2B transfer master. So go ahead, because I already load the project, so it's already on here. So let's say I rename this because it doesn't want to interfere with the corresponding from the SDK examples. Let's say we just put it BMP280. Then press OK. Let's save it to the different name so it doesn't clashes with the one that we load from the embed SDK examples. So this will take a while. Okay, this is the we already changed the names, which is BMP280, FDF6, and so on. So we import SDK examples. For this driver examples, we go not select all driver example. Okay. So we choose driver example. We choose the SPI. Yeah, this one, and we choose SPI polling B2B transfer master. So this will be load up the SDK example. So I get actually from the BMP280, I take this as a reference, which is the SPI polling B2B transfer master. Yeah, so this will take a while to load the SDK examples into the project. So this is actually just a reference. So you can see this is a basic initialization for the SPI here. Okay, that's for that for now. So let's go back to our project, initial project for BMP280. We go ahead and build it. So this will build the binary file, which is .axf file for MCUXpresso, which is the NXP microcontroller. This here is AXF file. So take the binaries file here, we copy, paste it into the desktop here. Let's go ahead and paste. Okay, now we're done. Load up your link flash here. Open up your link flash, load up the binary file. So this will be refreshing our probe. So let's see, detect our probe here. Refresh. Okay, detected I'm using FRDM MCXC444. Browse to the respective binaries. Choose here, open. Then we're gonna just program it. So it's BMP280, yeah. So go ahead, same things. We go to the Teraterm. Open up your Teraterm. Go to your respective COM port. For my example, will be COM9. Okay. So you can see now it's loading the garbage data because the serial baud rate is different. 9600 is set it. So go ahead and choose 11520 and click OK. Then this will be load up. Let me press the reset button here. Then we can get the temperature data. As same is, I cannot get the pressure. I think it's the chip itself is the counterfeit chip from China, or I'm not sure about that. But I am able to, after compensate the temperature, I'm able to get the temperature data. Okay, guys, that's it for the SPI communication for this time. Thanks, guys, for watching. See you. I think I'm will be more making different kind of project as well as along with the FRDM microcontroller. Thanks for watching. See you next time. Bye.